Hi everyone, thank you for being me. Thank you to the Build Stuff team for having me over. Really glad to be here. Today I'm going to be sharing with you my talk about advanced RAG techniques with Elasticsearch and OpenSearch. So let's get started. So first of all, hi, I'm Lisa. I'm a mom of one toddler, 3 cats, and 1 husband that desperately tries to keep up with us all. Professionally speaking, I'm a software engineer, team lead, and solution architect. I formerly worked for Elastic, so that kind of explains my personal connection to the topic and also might explain my personal hatred for slow queries. And today I'm a GenAI team lead at a company called Big Data Boutique. We do big data and GenAI projects, everything ranging from small POCs all the way to production. And I know it's like a very technical talk, but before we actually jump into the technical and advanced bits, I want to briefly talk about history. Now, don't worry, it's not ancient history, just the history of software engineering. So software engineering is a practice. It's like, I don't know, several decades old, like 50, 60, 80 years old. Mobile applications, almost 2 decades old, which makes me feel very old because I remember when those started. Single-page applications, machine learning, DevOps, all of these practices are 10+ years old. And then there are LLM applications, which everyone is talking about, right? Now, that's not to say that LLMs themselves are that new. Transformer architecture has been around since 2017, but the ability of you, me, every person in there to access an LLM via an API as a tool or as a service, that's a brand new capability. So that started only like in late 2022 when ChatGPT was released by OpenAI, right? So, so you can see this Google Trends chart here. The blue line is LLMs trending on Google, and the later lines, the lower lines, are other buzzy terms that you see on LinkedIn, like agents and RAG and MCP, all of those super buzzy terms that everyone is using, are literally 1.5 years old. So I think it's no surprise that if you're trying to actually build a good, reliable, production-grade LLM application, it's not that easy. It might sound easy if you're on LinkedIn or you're reading the Medium posts, but it's not actually that easy. So because I'm assuming that most of people present here are software engineers or engineering related, I want to go back and talk about design patterns and architecture, which are the things that actually help us build good software. So first of all, let's talk about what LLM applications are. So we're not talking about building models, training models, fine-tuning models, or deploying models. That's not what we're talking about. But we're also not talking about building software using like code. Are you? Oh, I thought you were asking a question. Sorry. Sorry. So we're also not talking about like building software with code assistance. Like we're not using Copilot. We're actually talking about using an LLM inside of an application to deliver new functionality, new features to users. So can I have like a super quick raise of hands? How many of you have actually built LLM applications before? Okay, few people. How many of you have delivered those to production? Even fewer people? Cool. So this is why I think it's really important. Like I think like 80% of the talks here are AI related, but it's not something that everyone has done. So I really think it's important that we talk about these things. So the first thing that happened, I think it was November 2022, exactly 3 years ago. And what happened was that ChatGPT was released, everything was amazing, but the actually cool thing was the ability to access it via an API. You didn't have to know anything about how LLMs work internally. You just like call it like any API, you give it some input, it gives you the output, and it's cool. Like that was a cool thing back then. And immediately all software engineers could start building around it, so we started tinkering with it and seeing like what we can build. And immediately, obviously, frameworks, tools, design patterns, architecture started to follow. So the first architecture, which was all the rage in 2023, was chatbots, right? You can build a chatbot on top of an LLM, so you can take your LLM, you give it some cool prompt, make it useful. Let's say you tell it to talk like a pirate, or if you want to be like more useful, you tell it like your business hours and your store locations, and you can ask questions about those, right? And if you give your application some operational memory, then all of a sudden it becomes a chatbot. It's like, it's a useful thing. I know it sounds a bit dated in 2025, but it was a very useful thing and you could do a lot with it. Sorry. The next pattern, and I don't think this one is talked about enough, is workflows. So let's focus on the commerce example. Let's say you have your store and you have a job that runs weekly and sends a report to your stakeholders about, let's say, revenues and sales, useful stuff. Let's say all of a sudden you took and added an LLM-powered step into this application. It could do something very simple. It could do something as simple as fetch a bunch of product reviews from the past week, right? Look for the best ones and the worst one, and just simply attach them to the report that you're sending out. And immediately, your stakeholders suddenly get context, right? So if, let's say, a product that has like terrible reviews last week, maybe it has a defect that could explain your high product returns, like if you have higher return rates than normal. If a product has amazing reviews, you might want to promote it next week, like, take an action item, promote it next week. So there's no UI here, but you added a very, very important and useful functionality to your product just by integrating an LLM. Sweet. And then there's RAG. And as I mentioned, it's a really new thing. It started like somewhere in early, mid-2024. And RAG started gaining popularity because people wanted to build real applications. They wanted to use real context, real data sets. And LLMs have this limitation that is called the context window. It's just pretty much the size of the input that you can pass it, right? So if you want to use like a large data set, you can't really put it all in the prompt. You need to pick and choose what you're putting in there so that you can make it work, pretty much. So RAG stands for, and I know it's a buzzy word, it's like a very buzzy term, but RAG just stands for Retrieval-Augmented Generation, right? So if we continue with our e-commerce example, let's say you want your agent now to be able to talk about your customer orders, right? You obviously can't and don't want to put all of them into the prompt, right? Like that makes no sense, it's private information. So instead, your application is going to take the user's question, fetch the relevant orders, and then pass them on to the LLM to answer the question. So that's pretty much what it is. It's no magic, it's nothing fancy. It's just the idea that you're going to retrieve data from a database and pass it on to the LLM to answer a question. That's it. Nothing fancy. And then 2025, I think it was like the year of agents, and everyone is talking about the agentic AI and MCP. But actually, in reality, all that it is a very software engineering-y move on building RAGs. And what happened is, like, when you were trying to build RAGs, there was a lot of repeating code. You need to access your database, you need to access many tables, and we engineers, I'm assuming that we engineers, we don't like to repeat ourselves. So we like to encapsulate things. So what people did, we took our database access logic and we put it into something we call tools, which is also just a fancy name for functions with a certain API. So we created those functions that we could encapsulate our database access behind. So let's say if we want to get orders, we would call a get orders tool. And if we want to get the shipping information, we would call the get shipping tool, right? So you have those functions, and now we can write our applications more easily. It's less complex. It's much easier to make changes, make updates. But then people started realizing there was something cool that you could do with it. You can actually let the LLM do the orchestration. You don't have to hard-code your flows. You can actually let the LLM, to pick which functions to use. So if you, let's say, want to answer a question about orders, then you can use like the LLM knows to call the get orders tool. If you want to issue a refund, for example, then you could, first of all, call the get orders tool to get the order. And then the LLM will say, oh, I need to issue a refund, so there's a tool for that, right? So that's the whole shebang. Like you build these functions that do the database access. Once again, still RAG. You're still using each tool to retrieve information, and then you orchestrate it either by yourself or with the help of an LLM. And one last thing, if you heard agentic AI, it's just the idea that tools can also have side effects. It's not purely read-only. It can also write, can make changes. For example, if you are issuing a refund or like making a return, the tool can also generate the return label. So the second it has a side effect, then it's agentic. Cool. But this just comes to show you that these architectures are pretty simple. We just took this API that has an LLM behind it, and we just built these normal patterns on top of it. how to build applications. So now that we know what happened in the past 3 years of history, when should we use RAG? So I've seen more cases than I can count of use cases that could be solved without an LLM, which is the best always, or with a much simpler architecture. So to understand when to use RAG, I would actually focus on the limitations of LLMs. I think what's important to remember about LLMs is that they are models. And models are trained on snapshots of data, right? They're trained, and then they stop learning. They don't learn anything new. If you remember a couple years ago, if you asked any model about something that happened very recently, it would tell you, like, sorry, I don't know. I was trained on data up to this and this date. Sorry. Today, models compensate by... Today, chatbots compensate for that by having access to the internet, right? Like, they can access the internet, fetch relevant information. But if you are building a business use case, if you're building like an actual production-grade system, I'm not sure you want to rely on, information from the internet or on information that was, maybe scraped like 2 years ago. For example, if you have your shipping policies on your website, they might be, like the LLM might have seen them, but they might have changed. Like, I'm not sure that you want to use those outdated pieces of information. And obviously, if you're using something, internal, your customer orders, your customer profiles, if the internet has seen them, I think you have a much bigger problem than RAG, right? Like, that's not good. I would check with your security team. So if you want to build a production-grade application that needs any type of access to information that you own, then it's your role to provide that to the LLM. Now, there's another thing that I want to address. I always get asked about that every time I talk about RAG, and that's the statement that RAG is dead. And obviously, this talk is not relevant, and we can all, go home. So it's a very nice title. I've seen it around since 2024 when RAG started. I click on this article. It's very clickbaity. But honestly, if we remember what we just talked about what RAG is, it's just the concept of retrieving data from your database and passing it to an LLM. There's nothing mystical about it, nothing magical about it. It's just retrieval, right? So as long as someone doesn't develop a new model that is like omniscient, omnipotent, knows everything in memory all at once with low latency for like 15 cents a month, then no, RAG is not going anywhere because we still need to retrieve data from databases, right? And it doesn't matter how big context windows get. It doesn't matter how fancy the model themselves get. You still need to retrieve data from a database and pass it on, right? And in every case that I've seen of production systems, when you narrow down the search, when you reduce the noise, systems become better, cheaper, faster, and generally more efficient. So no, RAG is not going anywhere. It might change names. It might be called something else next year, but the concept essentially stays the same. So don't worry, we're talking about relevant stuff. I'm not wasting your time. So now we can actually get into the technical bits. So what is RAG? Like, what is the actual anatomy of a RAG system? So every RAG that I have seen so far has 3 parts, right? The first part, and that's the most important part, in my opinion, and it usually happens kind of behind the scenes, so I think it's worth mentioning it, and we're going to come back to it a bit later, is document pre-processing. And this is the part where you actually do like the product work. You need to map out what you want your agent to talk about. So I kind of call it the question space. What topics would you like your agent to talk about, right? Like, do you want to talk about customer orders? Do you want to talk about the policies and the information on your website? Do you want to talk about the product inventory? Do you want to talk to your customers, or do you want to talk to your back office? You need to make those decisions. And once you do, you're going to get the documents, right? You're going to get the documents, the tables, the databases that you need as data sources for your agent, right? And when you map those out, you're going to see some areas where you have maybe numeric information, tables, but some areas are going to have text. And this is the most interesting part because there's a lot of information there. So the way you process textual information is that you do some pre-processing, and the pre-processing does something interesting. You take those text, let's focus for the sake of this example on the information on our website. So shipping policies, return policies, contact information, like all of that information that is on every e-commerce website. So you take that information and your goal is to cut it into pieces. and you can sometimes also refer to as chunks. And the goal with those pieces or chunks is that each chunk should talk about one certain thing, one specific thing. Weird. So I don't want to have like sentences or words, but I also don't want to have like a whole page with 10 different topics. And it's a very strange requirement, right? And the reason that I do that is because the next thing I'm going to do in the pre-processing phase is to pass it through something called an embedding model. Now, I can speak for a whole hour on embedding models, and I do. Like, I have a talk about that. But essentially, they do something really magical and cool. They extract the meaning from text. Okay? And I know it's a bit like of a large statement, but the best way I can explain what extracting meaning means is by providing you with an example. So let's say we have two different questions. One is like, hey, I would like to return my order. The other one is like, hey, what the hell is going on with my order? I hate you, you're terrible, where is my order? I want to cancel everything, some curses. Syntactically, those questions are very different, right? Like, they have different words, they use different language. I couldn't curse, but, you know. So they might be very different. It might be very difficult to understand that they are essentially the same question, right? But a good embedding model is actually able to capture that similarity. It is trained to capture that similarity, and it is able to represent that similarity as vectors, okay? So if you have two very similar questions, they're going to point in a very similar direction in that super high space, and two different questions are going to point in, you know, more different directions. So they kind of represent the meaning of the original question in that space. So once we believe that that's what an embedding model does, we can take those texts, like the chunks that we cut, with the vectors, we're going to get a bunch of them, and we store them in something called a vector database, which is just a database for vectors. Pretty simple. The second part is the fun part. You build the application, so you have your interface. Maybe it's a chat interface, maybe it's a search bar, maybe it's something new that I haven't thought about yet, but you let the users provide a query or a question. So let's say the user asks, hey, where is my order? So I'm going to pre-process that, and then I'm going to run it through also an embedding model. The embedding model will do what an embedding model does, and that's extract the meaning from the user's question, right? And I'm going to take that meaning, and I'm going to search the vector database, which is exactly what vector databases do, and hopefully, if I've done everything right, so, you know, to this point, I'm going to get the relevant documents for my question. So meaning for meaning. Then it's the easy part, answer generation. I'm going to take all of those documents. I'm going to like process them together, put them in a prompt, send them to an LLM, and if everything is fine, we get the answer. Everyone is happy, everything is great. And if this was an introductory talk, this is pretty much where I would finish the topic, right? But this is an advanced talk, so we're going to move to the advanced bits. We're actually going to go through the journey of building this thing together. So the first part of actually building any RAG or agent, is actually picking a vector database. It might be abstracted behind something, but you still need to choose it. And if we were having this conversation 3 years ago, I would tell you this is a significant decision. Like, I would tell you maybe you want to evaluate like run Faiz locally, and maybe you want to like try Pinecone because it's usually very easy. It's like a managed solution. Maybe you want some OpenSearch tools. And the reason why it would be a significant decision because those databases used to have different features. They used to have different algorithms. They used to support very different scales at very different costs, right? So it would be a significant decision from the perspective of software, like system architecture. However, I want to make a bit of a controversial statement. As of today, all of the databases support the same features. They have complete feature parity. They all support indexing, updates, vector search, hybrid search, filters, keyword search. They all have the same features, essentially. And if you have like this normal use case, and a normal use case is like tens to hundreds of thousands of documents, actually, then any vector database is kind of fine. I'm not saying like don't evaluate your database, but if you already have a database that supports vector search, you might want to consider using it. It's, you don't have to add another component to your stack from perspective of, operation and maintenance. So it's very convenient. And the reason why I like using Elasticsearch over OpenSearch for the sake of this talk is because many organizations that already do search have it. So it's a very useful tool to use. PostgreSQL supports vector search. Redis supports vector search. I think almost every vector database, like in Google or like AWS, supports vector search. Even S3 supports vector search. So it has become this feature. It's not a very like advanced technology to this point. So just consider the one that you already have. It's a good thing to choose. So now let's focus on the real scenario and actually build this search. And for the sake of our talk, I'm going to focus on Elasticsearch because that's what our imaginary e-commerce store has. So let's say it's the weekend, and I want to do some online shopping, and I'm kind of going online, and I decide to order some shoes. So those shoes arrive a few days later. They are nice shoes. They're fine. They're okay, but I'm just not excited by them. Like, I'm not vibing with them. So that's when I reach out to customer support and I get Bob. Bob is super, super helpful. He's really eager to help me with my inquiry, and he brings up my personal information, and he brings up my orders and the company policy and similar tickets. He might even check like my conversation history to see if I'm not a scammer. So he reads through everything, and a few minutes later, he returns and tells me, like, hey, since you live in Europe, you have 15 days to return your package. Go ahead, print your shipping label, send them over. And I'm very happy. I send my shoes back, and I'm very content that I was able to return the shoes. Unfortunately for Bob, his company decides to automate his job and replace him with an AI agent. And that's usually the point when they call me. So, or someone else. And if that someone else was to follow the example that I just showed you about how to build a RAG system, like how to retrieve the data in order to answer the question, they would do something like very similar to what is shown here. This is like a simplified version. So they would take the user's question, hey, how do I return my order? They would run it through the embedding model, and then they would search Elasticsearch, OpenSearch, whichever vector database they're using. So if we actually look at the results, at first look, they look kind of fine. I get a relevant result in the first place. However, I also get a bunch of garbage chunks, some low information, like low density information chunks, like return policy, that's just the title. I might get some documents that are like kind of okay, they seem kind of relevant, but they don't really help me answer the question. They're talking about returns, but it's not the kind of returns that I want. And the worst thing is actually they don't get the European return policy. So that's a specific one, like I have the global return policy, and there's the European one that limits me, like limits the return time to 15 days. I don't know if that's actually the case, but I just assumed it is. And if I were to try and generate an answer based on these search results, I would get literally the wrong response. It would hallucinate, right? They would tell me like I can return within 30 days, then I would miss my return window, and everyone would be sad. And this is the point where people often go and try to optimize search. And I want to recommend that you never do that. Before you try to optimize your search, you need to make sure that you're not putting garbage into the process. So you need to make sure that your chunking and your embedding strategy, everything within the pre-processing stage, was actually done correctly. So this is the point where you want to go back to your chunks, go back to your data, review it, make sure that you remove unnecessary characters. Maybe you ingested HTML as text. Maybe you have like a bunch of CSS tags there. Maybe you index the menus. I know it happens. So you want to make sure that you clean those up. Then you want to make sure that your chunking was done correctly. So I mentioned that, and I really emphasize that you want to make sure that your chunking represents a single idea in each chunk. Maybe you cut sentences in the middle. Maybe you put too much into a single chunk. You want to review those and make sure those are done correctly. You might want to make sure that the formatting is good. Once again, make sure there's no like garbage in there, menus, like logos, metadata text. You might want to attach titles to each chunk. Let's say if you have a section that talks about the coverage of an insurance policy, that is only clear if you attach a title to it. So you might want to add the title to each chunk, and obviously review your model selection. So you could choose different models for multilingual use cases, for English text, larger vectors, smaller vectors. There's a lot of things to tune there, but eventually it's pretty easy to get to a point where you look at the chunks with your own eyes, and they look fine. Each of them has a clear idea, they're all clean, no garbage characters, no emojis, like it's good text. You can see that with your eyes, it's pretty easy. And this is the point where you actually want to move on to optimize your search. So with your chunks being fine, but you've been already burned by semantic search. So you might want to decide to try something like a old school approach, but with a modern twist. And that's when you might try keyword extraction. So using the LLM to process the query and actually extract keywords from it, and then use normal keyword search. Like we don't like semantic search, it's not good. And I've seen these exact steps, like these exact thinking processes happen with customers. So let's apply this to our own question. We take the question, I want to return the shoes I ordered, and we use the LLM to just extract keywords. We're not doing anything fancy, just giving the keywords in this question, and then we'll use those keywords to search the database. If we look at the results, once again, they look fine. They look okay. It's very clear why each result shows up in the list, right? They all have a high keyword density, depending on how I implemented the search. However, I don't get the global policy, I don't get the local policy, the regional policy, probably because it didn't have enough keyword density in there. And I won't also get anything that has acronyms. Let's say we had a document that had the word footwear instead of shoes. I wouldn't get that. With semantic search, I would get that result. So once again, I might get a good answer, but I might not get a good answer because I didn't land on the documents that I actually wanted to see. So can I do any better? And the answer is obviously yes, because otherwise, why would I be here? So you can try two approaches. The first one being semantic search plus metadata filtering. So we're going to kind of combine the two previous approaches. We're going to do semantic search, but we're going to limit the area that we actually look at by using filters. So let's go with our question. I want to return the shoes. I'm going to use an LLM to extract a label. I'm not going to extract keywords. I'm just going to extract labels from a closed list of labels that I will provide it. And it tells me correctly that the question is about returns, right? I'm assuming that I have previously labeled everything in my database with appropriate labels. So that's work that I need to do. And then I also have the location, which I don't need an LLM for. I have that from the user's profile, right? Never use an LLM for something that you can do without one. And the reason why this works is that the label actually limits the area of the index, the part of the index that we do semantic search on. So we don't have to search the whole index, and hence increasing uncertainty. It's a heuristic algorithm. It's not precise, and it might find things that are irrelevant. We're actually limiting the part of the index that we're looking at. So this is the first time we're able to find the right documents. So we get both the global policy and we get the regional policy because we filter down to a very small area of the data set, and then we're able to get the right documents. And here, if we actually generate the result, we'll actually, for the first time, get the right result that Bob, who was already fired, was able to give us. But can we do any better than that? And the answer is yes. There's actually a pretty generic technique that works for most cases. This is my personal baseline when I try to build a system. This is what I start with. And it's called hybrid search plus RRF. And what it's like, once again, fancy name, buzzwords, but essentially it does a very, very simple thing. It just runs both searches in the same time. It runs a keyword search with filters, and it runs a semantic search with filters, and then it merges the result into a single list. That's all that it does. And luckily for us, like I told you, most vector databases have feature parity, so most vector databases already have it implemented, and you can call a hybrid search with any database, and it does it magically for you. And RRF is just one way of merging the results. What it does, it combines both the result lists when each document contributes to the score. I'll show it on the next slide. So let's say we ran hybrid search with our question that I want to return the shoes that I ordered. And we can see that the list kind of looks familiar. We actually have both result sets in different order, right, in the same place. And this is going to give us very good coverage for our question. We have the semantic results that includes the synonyms and the background and the understanding of the topic, like the meaning of the question. But we also have strong keyword density. So we have a good perspective on the entire topic, and we're going to be able to provide a good answer on that. The way these results were merged, I didn't address this in the previous slide, is that you have two lists of documents, And the position of the document in each list is going to contribute to a common score. So if, let's say, a document is first on this list and third on this list, it's going to be pretty high in the combined list. If it's only in one list and not in the other, then it's going to land somewhere in the middle. And it's just one way of combining the result. There are multiple ways, but this is just kind of the default one. So it's what you start with, and then you can iterate, fine-tune, whatever. Can we improve it even further? So the answer is not really with the database itself. We can use something called a re-ranking model. This is something you would do after you get the result set. You use an AI model, a different model. You can use an LLM, but you can also use dedicated re-ranking models, which are cheaper and faster, to look at the question, look at the answers, and just shuffle them around by relevance to the question. So if we look at our result set, it's just the same documents, but now all of a sudden, the document that talks about my regional policy is all the way up high. I know it seems kind of weird, like why are we shuffling those things around? It's just the same results. Why do we need to reorder them? And the reason for that is that models pay more attention, like LLMs pay more attention to the beginning and the end of the prompt. So if you're just shuffling those things around, you're saying it like, hey, the first result is the most relevant, you're helping it give you a better answer. So if you have an evaluation, you will see like a small improvement on your accuracy. And one last technique before we kind of conclude this whole topic, I know it's been a lot, pretty specific to Elasticsearch and OpenSearch, is using time decay. So imagine that you have a domain with a strong temporal element, let's say news articles. So news articles from today about a topic are much, much more important than something from last week or last month, right? So you could multiply the scores of the semantic search, or like of the hybrid search, with a mathematical function that adds like this decay element to the score. So a document, let's say from today, would be twice as important as a document for last week, even if it was just exactly the same document. Now, for our example, it's not super important. Policies and website information doesn't have a strong temporal element. But if we, for example, had two versions of the same return policy, like one was like from 2 years ago and the other one is from this year, then maybe we're going to, like the new one is going to get a higher score. So I would use it, especially if I had like a strong time element in my search, but it could be useful in this case as well. So I know it's been a lot of techniques and a lot of technical stuff, and we've spoken about many things, but there's really one thing that I want to emphasize, and that's a word on evaluation. We've spoken about optimizing search, but there is an underlying assumption here, right? In our example, we knew what were the documents we were looking for, right? I knew what I was going for. Like I knew I wanted to get the 15, like the regional European return policy. But in reality, if you're building a real agent, like a real RAG, you have multiple questions and you have multiple correct documents, and that becomes the real challenge. And if you don't know what good looks like in the system, you can't really optimize for it. So as you're starting to design those systems, as you're starting to build, you need to have like some kind of a golden set of questions and answers to define what good looks like. And you need to make sure to evaluate that periodically. The most simple way, not the easiest one, but the simplest way is just human evaluation. You periodically run those questions and you look at it yourself, or you let someone like a specialist look at it and score the results. Not the most fun way of doing it, but actually a very decent way, especially for smaller projects. You can always integrate production feedback. Every application out there today has like the vote up, vote down. You might release something bad to production, but at least you'll know that you messed something up. LLM as a judge sounds very tempting. Usually, it's like very promising. Like just let the LLM decide if it's good or not. It's not always great, but it can be an additional pillar in your evaluation suite or like your ecosystem that you use to evaluate the results. And there's search evaluation, which is actually not a new technique. This was around from before LLMs, just the idea of not looking at the final result, but if you have a question and like you have 5 documents that are correct for this question, you can look them up. So instead of looking up at the final answer, you can look that the right documents were retrieved based on the question, which is an easier way of doing it. But it doesn't really matter which ones you pick to use. just make sure that you have something, because you can't really optimize something unless you know how your ideal result looks like. So time is running short, and I would like to summarize because we've covered a lot of topics, and I want to make sure that you remember the things that I find most important about this topic. So first of all, LLM applications are new. They're very new. It sounds like everyone is doing them. They're not. Just start building. Try them out. It's fun. Second, RAG is not dead. It's just database retrieval and augmentation. You just get things from a database and you pass it on to an LLM. It's just a buzzword, but the concept itself is not dead, so learn about it. Next, the best vector database might be the one that you already have. All vector databases are awesome, and if your use case is normal, just tens of thousands of documents is a lot for a customer support system, for example. So just use the one that you already have. Then get your embedding and chunking strategy right. You can't optimize a system if you're putting garbage into it. So make sure that you're not putting garbage before you try to optimize anything. Hybrid search, re-ranking, and time decay are very useful tools in my toolkit when I build RAG and agents. I start from there and then I optimize. They each have a lot of knobs that you can turn and improve your search. And finally, repeating that again, really important, evaluation is everything. You need to know how good looks at, because these systems are not predictable always. They are not deterministic. You need to have a system in place to recognize how good looks like. And I hope that you all develop agents and RAGs in the upcoming future, only if you want to, of course. If you don't want to, don't do that. That's pretty much it. Feel free to follow me on LinkedIn. That's our website of Big Data Boutique with consultancy. We also have our AI SRE for OpenSearch and Elasticsearch if you want to maintain your clusters. And if you want, we have a few minutes for questions.